Good evening, everyone. Welcome to week 11. This week, we'll be talking about ethics and safety. Um, those are two very important things in agentic AI development. Um, yeah, that's basically what we'll be covering this week. And as usual, we'll start with a recap of what we did in the previous week, which was context management and agentic retrieval. So, who volunteer to give us a recap of what we talked about concerning identity retrieval and context management.
Okay, so I would like to touch on a few things I was able to recollect like during last weekend. So last week we talked about the context like window, and the context window is basically the amount of um, amount of like knowledge the LLM has at a particular time, and it is like referred to as the working memory. The context window also has core components, which includes the system prompt. It also includes the chat history. It also includes the retrieval knowledge, and it also includes the tools and definition and output. And lastly, I think it includes the user input. So we then proceeded to talk about the constraints that the context window my memory has, and a couple of issues that it has. So the so when the okay so the progress or the performance of the LLM would behave a particular way when the context window is full, and that is what I can remember on that. And we also touched on what's a RAG is. So RAG is basically an open book which the LLM use, and it involves the retrieval of relevant information, using the vector-based and external APIs, which acts as a response which will be given to the user. So what's the RAG does for us is it gives us a specific and private information. It also allows us to avoid fine tuning, and what else? Okay, and we also did the patterns, agentic AI patterns. Like there's the traditional one that um, the user just make a query. So when you make a query, and you get the response back. So doing this, there is no thinking, or there is no deep thought which will go through. And there are pillars of the agentic retrieval, which includes routing, which also includes query, I think forgotten, like you have, which also includes, what's in that one? Routing, grading, and iteration. I think like I've forgotten like the other aspects of it all. So I think like I'm just like shuffling through my mind what I can remember. But maybe if like you can also like come in for me so that I could like relax my mind and like get like my thoughts right to add a couple of things that like I was supposed to mention.
Okay, thank you very much for that, Kenneth. Does anyone else have something to add concerning what
Yes,
we
sir.
talked about last week? Okay, go ahead.
Yes, sir. I want to just add because that class I left midway, but before I left, I was able to pick a few things. Although Kenneth had done justice to some part of it, but before I left, I knew you told us we started with RAG actually, retrieval augmented generation, and just like Kenneth said, it's like an open book for LLMs. And I know the open book is like maybe from the common term open book exam. Each one has an exam and is allowed to go to a reference material to get his answer from the reference and give it to the examiner. But in this context specifically, you told us that it involves fetching relevant information from sources like vector database and external APIs, using them as basis for the LLM's response. And from what I understand, it means that if a query comes or if a search comes, the instead of hallucinating or just giving an answer that is not very accurate, there's a provision that the LLM can reach out to, and that system is called the retriever augmented generation, which is it will augment what it has, like the user query will not be what it will work with. It will go to a vector database, and what is in that database is embeddings of knowledge that had been pre-stored, maybe due to proprietary data that must not be in the public, maybe some documents that are classified as should not be in the open. So they will be embedded and stored in the database such that when there's a need, the the LLM will determine that there's a need to, maybe based on the keywords there, that let me search for this word, based on the vector, the distance that I have told us before, the vector distance for the particular name now. They, based on that vector distance, to now retrieve the relevant documents and then mix them together and then generate the answer. So it's a much more accurate. So you told us it reduces, that's why it reduces misinformation, because the responses are anchored in verified documents. And one thing I want to mention here that I think Kennedy remember, maybe I didn't hear him, is that the need for this RAG is because we can't always be fine-tuning our model every time. Because fine-tuning will mean that we want to specialize the model or the agent, but there will always be development that will always happen. So instead of always fine-tuning, which is more expensive, we would rather do RAG so that the system will be context aware at all times. What I just want to add is that you gave us different, you said two types of RAG. So what I've known before, you called it naive RAG. In other words, maybe it's not a very smart one because it's just like a one-way traditional retrieval system. Because the other type you told us is called the agentic retrieval. And the specific thing you mentioned there is that this agentic retriever has another feature such that it gives LLM agency over its search tool. In other words, the LLM can decide on which tool. I believe it will have different tools available, typical of an agent, to do a function call. So the LLM can as well reason, okay, this is the tool I should call for this particular task, and it can do that in a loop, iteratively, I mean to say, such that it will rank the response and determine maybe it is good enough, or maybe it needs to. And you told us about the pillars of agentic retrieval, which is routing, query transformation, grading, and iteration. So I believe the grading aspect is the aspect of having to reiterate if the quality, so to say, is not good enough. Um, Apart from that, I think that's the basic I can speak to. Others, I wasn't really in class.
Okay, thank you very much, Olana. You actually added quite a bit of to. The only thing I think I would like to add is that the context window is fixed, so it has a fixed length. So whenever it fills up, for you to add more information to the context, something has to drop. And typically, the older information is dropped in order to allow the fresh context to be uh, added to the window. And also that as the context window fills up, the LLM's performance drops. Of course, the larger the context, so the higher the API costs as when you're using the paid provider. Of course, considering that the LLM provides the reasoning core for um, agentic, most AI agents at this as of today, um, it lower the performance of the LLM, they lower the performance of the agents too. Um, Another issue related to context is the needle in the haystack problem, because LLMs typically they tend to remember more the information at the beginning and the end of the context, and they don't have poor recall of the information at the middle of the context. Yeah, but that's just what I wanted to add. But unless somebody has something that has that something really important that we have missed that person would like to add. If not, then I think we should move on to what exactly we have for today. Okay, so we move. So today we'll be talking about ethics and safety uh, in agentic AI, and in talking about ethics, um, one key aspect in discussing ethics will be fairness. Fairness. So, what really is fairness? What are the things? Key? Um, what are the key perspectives to fairness? What are the key components of? Well, I guess perspective is a better term here. What are the perspectives to fairness in agentic AI? Um, so when we talk about fairness, we look at distributive fairness, procedural fairness, and representational fairness. Distributive fairness has to do with, um, for example, let's say you have an agent that a flight booking agent, for example, and let's say the airline has a promo. Does everybody who tries to book a flight using that agent have similar chances of getting that promo? Of that, does that agent try to fairly provide or take advantage of that promo for anyone who tries to use book the flight through it, or does it give a higher chance to people who belong to a particular race or a particular social stratum, or who live in a particular area? I mean, how fairly does the agent distribute? Does the agent how do I say how fairly does it act on behalf of um, users across different demographic groups? So if it's not fair across different demographic groups, then the distributive fairness is poor. So that means it's skewed in favor of some certain groups as against others. Now, procedural fairness is about the logic of the agent, how it's the steps it takes in carrying out its tasks. Is the logic consistent, or does it apply different criteria to different classes, different groups of people? For example, let's say an agent that is supposed to evaluate resumes and recommend those that meet the basic criteria for a certain job. Does its evaluation, does it use the same rubric for everyone, or does it use different rubrics for people in different from that belong to different demographic groups? For example, people that have different characteristics or whatever. And then representational fairness has to do with stereotypes. I mean, if the agent in its communication reinforces certain stereotypes, then the representational fairness is poor. Does anyone have any questions so far? Okay, so we continue. The other thing we need to talk about while we're looking at ethics in agentic AI is equality versus equity. Yeah, when we say fairness and when we talk about does the agent offer the same fair, how would I say it, the way the agent treats requests from people from different groups, is it fair? What does that fair mean? Do we consider it to be fair when it gives the exact equal treatment to everyone? So exactly the way it treats group A is the way it treats group B. Is that what we consider as fair? Or is it that it says that let's say group B is marginalized, maybe they have the median income or the median disposable income or their whatever average disposable income for group B is much lower than that of group A, and so the agent now um, awards more of that promo to those in group B who are more disadvantaged. Would we say that that is in such a condition that the agent is fair? So essentially, would we consider fairness to be about equality or about equity? And I think at this point, I would like to hear what you think. Which one would be a good representation of fairness? Equal treatment by the agent or equitable treatment by the agent?
Can I speak, sir?
Please go ahead, sir.
I would think equity is fairer than equality based on what you have just told us. And as you brought this slide, I remember a particular um, picture of whatever I've seen before, that two people were standing behind a fence and they were watching football. Maybe the fence is about 4 feet tall, high. The fence is 4 feet high. The two people were standing there. One of them is 5.5 feet tall, so he's able to naturally see the football pitch and see the match going on. But the person who is maybe about 4 feet tall, could barely even his head could barely even raise. So what they now brought to help them is, I think there are about 10 books that they, or maybe let me say 10 pedestal or 10 blocks to give them to stand on. So they only gave only 2 or 3 to the guy who's already 4, or let me say 5 feet tall, who is able naturally to see the field. They gave him 3, but they gave the other guy who is about 4 feet or barely the same height as the friend. They gave him about 7. So while that was done, they both came at the same level. Who, even though they didn't have equality in the share, but it came out to be fair. I think that gave me a better understanding of what you said, sir. So that's why I feel equality is fairer than equality. I mean, equity is fairer than equality. Thank you, sir.
Okay, thank you for that. Does anyone have a different opinion, or would anyone like to add some further perspectives? I mean, if you support what you had just said, do you have further perspectives to add to it, or do you have a different opinion from the one Olara presented?
Okay, so I would like add like I will add like one or two to it. So like based on what I have learned throughout this program, um, I've I have come to the conclusion that we are supposed to work like based on the requirements of being like usage. So, like what are we like using it for? So, like what we are using the specific needs for, and like that's what like you need to choose. So maybe I will use um equality when I am making a let's say a prototype or building a simple chatbot. And I will also use equity based on the use case of building a production grade agent. So based on the use case, I will use what is being like required for. So like based on the tags, I will search for the specific tool which is desired of me to work with. So and that's what I have to say.
Thank you, Kenneth. And does anyone else have something to add? Yeah, this one goes. Now, so I am Alara is saying that he feels that equity is fairer than equality. Kenneth is saying it depends on the exact use case. Okay, so let me ask, in giving the example that Olarewaju gave, um, let's assume that the football match that those persons were watching is ticketed, and let's consider that the books they were given could be sitting. Okay, maybe the shorter one is given a preferred position, maybe in front, while the taller person is given a seat at the back. Now, assuming the two of them paid the same cost for their tickets and it's same category of tickets, is it really fair to give one person a better sitting position than the other, even though they paid the same for the same category of tickets? We really say that that is fair, even that one person is getting more than the other, even though they paid the same.
Is it for me, sir?
It's for if everybody, anyone who would like to um, respond, go ahead.
Okay, sir. Let me just respond briefly. I would say it is fair, in my opinion. But my reason is because since the whole goal is to remove bias, and bias can come from anything that we may not even know. So I would say, even though they pay the same tickets, but since one person is disadvantaged, we may allow that the person be given a chance. Because in a fair competition, may not stand a chance. For instance, we know that maybe in Nigeria, some people in the north and those in the south have different popularity in terms of academic exposure. And I think even in admission quota, they usually give them some leverages, some advantages, so that, but if you should apply the general rule, you may not see 5 of them getting admission. But because of that, so in my opinion, I think even though they pay the same amount of money, just like everybody have access to the same syllabus, the same brain, but due to one reason or the other, some are disadvantaged, we could allow them to have better access to avoid bias. My view, though. Thank you, sir.
Okay, you're mentioning bias. Well, bias is really about treating some people better than others. I mean, treating some people differently because of some maybe their race, social status, or something. That is what bias we are. So if that is what bias is, wouldn't equity now become some form of bias, since you're treating, in this case, you're giving the person who is shorter a better position? Wouldn't that be some bias against the person who is taller?
Well, I
Kenneth,
think
you
it may
can go
just
ahead.
make them to come at par, kind of.
Okay, so like what if there are maybe like rules like to be followed? So during this maybe like we are going to a cinema and I get there first. So whilst I get there first, I will try to pick the seats which like favors me. So maybe like there will be a rule like that. So like so far as I get there, I pick what favors me, and like the next person will also follow suit. And like that is my perspective on that one.
Okay. Anyway, the important thing here is that there's no right or wrong answer in this case. It really depends on the context, but equity is really about trying to be human and humane, trying to help the weaker person to be at par with the stronger person. So it's really about humanity and the specific context, but there are some contexts where okay, for example, football, you want to form a team to go and play, let's say, the World Cup. Would you use equity in this case, saying, okay, let's give quotas to people from different places, or would you prefer to have your best players in the team? This is not a question, it's just a scenario. So really, whichever option you choose, it's context dependent, and there's really no right or wrong answer choosing between quality and equity. It really depends on what is your objective. What are you trying to achieve? Anyway, let's move ahead. Now, fairness and utility trade-off. Now, when you've decided whatever qualifies as fairness in the context of the agent you're building, you need to be aware that sometimes to achieve that fair treatment by your agent, you might need to compromise on its utility, on its effectiveness, on its efficiency, on its accuracy. So you may need to lose some utility in order to achieve better fairness. Essentially, um, increasing fairness tends to reduce the agent's raw performance, right? And if you want to, let's say if you want to achieve fairness, like um, enforce demographic parity in your agent, demographic parity in that your agent tries to, like in the case of the resume evaluation agent. The agent tries to see that in the resumes it recommends for, let's say, moving to the next stage, it could be interviews, trying to see that all demographic groups are equitably or equally represented, depending on whether you are trying to target equality or equity. So in trying to enforce demographic parity, you may end up lowering the accuracy, for example, of your model. And so you need to, there's a trade-off between fairness and utility. And as an agentic AI developer, you need to achieve a balance between the two. So you need to tune your agent to the point where you maximize utility, maximize, maybe if your measure of utility is efficiency or accuracy, you maximize your accuracy while keeping it reasonably ethical without making it, well, here I say crossing without crossing ethical red lines. There's a threshold below which, if your agent's fairness is below that threshold, it's really a red line. That is really becomes really concerning. So the objective would be to ensure that your agent's fairness is above, your agent's fairness level is above this threshold, right? While also optimizing, essentially it's optimizing utility and fairness. So you have good utility as well as good fairness. So you need to achieve a balance between the two. You cannot have, it's rare to be able to achieve perfect utility as simultaneously with perfect fairness. That's essentially the summary of what I'm saying here. Any question so far? No questions, so we'll move ahead. Now, responsible AI is really about, responsible AI principles are really some principles that are somehow guaranteed to achieving fairness in your agent or your AI system, your AI product, as the case may be. Now, the core principles in responsible AI are accountability. Now, accountability, let's say your agent takes an action, right? If that action goes south, if the consequences of that action are detrimental, who is held responsible for that? Who pays the price for that negative consequence? That person that's accountable. So you need to ensure that you are accountable. You need to be accountable for the actions of the AI you build, or whoever is running that AI system. So somebody has to be accountable for the actions of that agent. Because when you are accountable, then you need to ensure you do your best, typically, to ensure that the agent's performance, the agent doesn't take unethical action, it doesn't take actions with negative consequences. Another core principle will be transparency. Essentially, this is how much insight do you have into the logic that this agent applies as it executes? How much insight do you have into the processes that it follows, the steps it follows to arrive at, take a decision to arrive at a result, how much insight do you have to this? How well do you understand those processes, the logic that drives the agent? That's transparency. Because if you don't have adequate transparency, you may not be able to figure out whether or not there's fairness. And if or you may not be able to figure out, and if there's some fairness or bias, you may not be find it easy to identify what exactly is driving that bias. And then privacy and consent. How um, how does your agent handle PII? PII is personally identifiable information. How does your agent handle PII? That's what this has to do with. Consent. Before you handle people's private information, do they consent to it? Now, if you are persisting PII in the long-term story memory of your agent, is it redacted? Is it what's the probability of your agent leaking people's private information? So those are things that have to do with privacy and consent. So these three form the core of responsible AI principles. Any question? Yeah, Kenneth, please go ahead.
Okay, so I want to ask, maybe I am building an agent which is related to the health fraternity. So, and I've built it complete, and I give a caveat that I think that they use this caveat. AI is not 100% all of that sort. So whilst this caveat is being given, and let's say maybe that the user that queries my agent and maybe gets a feedback, or let's say a response that he or she uses, and maybe there is a issue, how should they hold me on? Because I have given a caveat that use this at your own risk. So I think just by giving that caveat, does that prevent you from being taken on, because you've given a caveat that use this agent as your own, or this wouldn't give you a maybe 100% accuracy. So that's my question, and yeah, that's it.
Liability really depends on your the operating, or is it operational landscape. I mean, in certain jurisdictions or certain professional areas, you would still be liable, even if you had put that caveat. In some others, you may not be liable. So you need to know exactly what applies in your use case, and that should guide exactly how you build your agent. But let's assume you don't even have liability, right? Let's assume that in such situation, legally, nothing is binding on you. What if today there's a lot of social media and all that? The person now posts this on some social media platform, and it goes viral, and then there's public backlash, and then nobody uses your service anymore. It's possible, even though you're not legally liable, it could also have negative impact on you. So you need to consider the landscape within which you are operating, and based on that, you take the best decisions on how exactly you have to build your agent. And then you need to try to ensure that your agent doesn't take actions that would be negatively impact either the users or you, the builder, or those who are running that agent. Those are the things you also need to take into consideration while you're building the agent. We're going to look at some of strategies for mitigating such occurrences later in the week. So we continue. So we'll be looking at AI ethics toolkit. I've tried to curate some tools that are useful in the ethical evaluation and so on of AI agents, including visibility, like we talked about, transparency, then which is one of the core pillars of the fairness and ethics and responsible AI that we're talking about. The first we'll look at is the AIF 360, which was developed by IBM primarily. This uses classification metric and binary labeled SSI objects to calculate utility and fairness metrics of AI systems, including agents. So it enables subgroup disparity between subgroups, and the utility, the trade-off between utility and fairness to be analyzed and visualized. That way, you're able to figure out the best way to tune your agent for optimizing utility and fairness. The disparate impact cleaner object of the AIF 360 can also be used to mitigate bias at the data level. That's the data that is used to train the LLM, which powers the agent. This can be used to mitigate bias in that data. And if you're able to mitigate bias in the data, obviously, when the LLM is trained with that data, its weights will also be representative of the level of fairness in the data. You train an AI model with data that is biased, definitely the model's responses will be biased. The next tool we'll talk about is Fairlearn, which developed by Microsoft. And in Fairlearn, you can use its metric frame and fairness dashboard tools to visualize this utility fairness trade-off and identify where it's occurring, which enables you to fine-tune. Well, I won't use fine-tune here because fine-tune has a specific connotation in the model training. You can use it to tune your agents to achieve a desirable balance between utility and fairness. And then the third we'll talk about will be Sharp and Lime. Sharp and Lime are used for explainability. So when you talk about explainable AI, Sharp and Lime are two tools that are typically used. Sharp means sharper additive explanations, while Lime means local interpretable model agnostic explanations. So these tools can be used to identify, help you figure out if a particular attribute, let's say certain attribute, maybe gender or race or age or height or HIV status or whatever, whether such a sensitive attribute is unintentionally driving the agent's decisions. So if you figure out that certain such an attribute is driving the agent's decision, then you will be able to modify your agent so that that attribute no longer becomes a factor driving the agent's decisions and outputs. Because if something like race is driving the agent's decision, then the agent is going to be biased. It means he's taking decisions based on race. Well, there are also scenarios where race driving decisions will be beneficial. For example, if a certain race is predisposed to a certain health condition, right, then you should, or a certain race reacts negatively to a certain medication, then it's good for that attribute to become a factor driving the agent's decision on whether or not to recommend administering that medication to that race. But where the factor of race is driving the decision of the agent, maybe to provide some benefit or decision to do something harmful to anyway, your agent shouldn't even be built to do something harmful to anybody at all. So assuming race becomes a factor to drive the decision to provide some benefits to people, then your agent will is already biased because it probably will be providing more benefits to certain races than others. In that case, that explainability, that insight into how or to what extent this sensitive attribute drives the agent's decision could enable you to know, hey, I need to mitigate the impacts of this attribute on the agent's decision in order to make my agent less biased. Any question? Okay, so at this point, we'll have a demonstration on using AIF 360 for auditing the fairness of an agent. I'm going to stop sharing and then I'll share my ID. Okay, please let me know when you can see my screen. All right, thank you for that. So here we are going to use we are going to simulate, or rather we are going to simulate a situation where data has been gathered from a number of runs of the agents, and so we'll use AIF 360 to audit the fairness of that agent based on that data. Here, the data, the agent in this case is an agent that's supposed to recruit specialists for a certain task. So there are a number of specialists that have been submitted to it is supposed to now decide whether each of those specialists meets the requirements for the task or not. So essentially, it's going to be hire or not, or don't hire. That will be what its decision will be. And when it says hire is represented by 1, don't hire is represented by 0. The inputs that the agent gets is the specialty of that. Okay, are recruiting agents. The input it gets include the specialty of the expert agents, the region from which those expert agents, their origin. Those are the inputs it gets. So for region, 1 represents global north and 0 represents global south. And then the agent has made decisions here where for the first, the agent here is a recruiting agent, has made decision where it says hire the first expert agent, do not hire the second, hire the third, do not hire the fourth, hire the fifth, and so on. But our ground truth, it's saying that the first agent is qualified, the second one is not qualified, the third and the fourth are qualified, the fifth is not qualified, and the sixth is qualified. So what we can infer from this is that the skills needed for this task will be coding and research. Writing is not a stable skill for the task. Now, our recruiting agent, it says hire the first expert agent. That first expert agent is a coding agent. So that decision is fine. It matches the ground truth. And then it says don't hire the second agent. And looking at it, that second agent is a writing agent, which writing is not a skill needed for the task. So, and that matches the ground truth. So that's fine. It says hire the third agent, which is the coding agent. That's fine. Don't hire the fourth. But the fourth agent is a research agent. And so research is a skill needed for the task. And that agent should have been hired. But it's saying don't hire that agent. And so this particular point, it doesn't agree with the ground truth. It says hire the fifth agent. And the fifth agent is a writing agent. Writing is not a relevant skill to the task. And so it shouldn't have hired that agent. And so his decision on the fourth and fifth agents are incorrect. Similarly with the sixth agent. The sixth agent is a research agent. But it's saying don't hire that agent. So it's correct in his decision for the first, second, and third agent, but his decision about on the fourth, fifth, and sixth agents, expert agents in this case, are incorrect. If we look at the region for these agents, we see that all the agents that it recommended to hire are agents that hail from the global north. So essentially, these are recruiting agent. Its logic is just being driven by if an expert is from the global north, just hire the expert. It's not considering the expert agent's area of specialty. No, it's not. It's just considering their origin. And that is a problem. It's biased. You see here, it's hiring some writing agents who are not qualified, and then some coding and research agents who are actually qualified. Is not hiring them simply because they are from the global south. So this agent is clearly biased. Anyway, let's run this code. Okay, let's finish the analysis. To be able to audit the fairness, we define the privileged and non-privileged groups. The privileged groups here are those from the global north, while the unprivileged are those whose region is global south. And the metrics that we'll be extracting will be the accuracy, the precision, the recall. That's for overall agent performance. And then we display this. We also evaluate metrics by region, where we check the selection rate for the global north and that for the global south, as well as the true positive rate for the global north and global south. True positive rate is the same thing as recall. And per region metrics here is trying to tell us whether the overall metrics, does it have a different trend from the per region? If a region's metrics are much poorer, a region's fairness metrics are much poorer than the others, that's showing that that region, there's a bias against that region. And then we also evaluate the statistical parity difference, as well as the selection ratio. Well, selection ratio here is simply the disparate impacts. That's the method that's used to calculate that. It's really about the ratio between the unprivileged group and the privileged group, and the ratio of their true positive rates. And then we display these values. So let's run the code. Yeah. So the accuracy is 50%. Looking at the data, we saw that the decision of our recruiting agent for the first 3 expert agents is correct, but it's wrong for the last 3. So that's 50% accuracy. Half of its recommendations are correct. Precision. Precision is really it measures what percentage of the positive what's the term?
Prediction.
Yeah, the positive predictions. What percentage of the positive predictions are correct? So the formula would be true positive over true positive plus false positive. So it's just percentage of the agent's positive predictions that are correct. Recall on its part is really measuring how much of the actually positive data points that it's able to get correctly. I mean, in this case, how many of the actually qualified agents is agents here means expert agents. How many of the actually qualified expert agents is our recruiting agent able to recommend that we should hire? And it's just about 50% of them too. How many agents are qualified? Coding 1, coding 2. There are 4 agents that are actually qualified, and it only recommended recruiting 2 of those. That's 1 and 3. And so it's still 50% recall. For fairness metrics, the selection rate for the global north is 1, implying that once an expert agent is from the global north, it recommends selecting it, which is what we also saw from the data. Looking at the agent's decision is exactly the same as the region data. So it's just essentially saying, hire everybody from the global north, don't hire anybody from the global south. And that's why the selection rate for the global south is 0. And the selection rate gap, which is the statistical parity difference, which is just simply the difference between the selection rate for the global south, that's the unprivileged group, the difference between the selection rate for the unprivileged group and that of the privileged group. That's -1. 0 minus 1 is -1. And the ratio will be the selection rate for the unprivileged group divided by that of the privileged group. 0 by 1 is still 0. Equality of opportunity, well, the recall for the global north is 1. I mean, it picks if all the qualified people from the global north. Those will be agent 1 is from the global north and is actually qualified, is a coding agent. Agent 3 is from the global north and it's a coding agent, so it's qualified. Which other agents from the global north? Agent 5 is from the global north, but it's a writing agent, so it's not qualified. So it's able to recommend recruiting all qualified agents from the global north. So each recall for the global north is 1. Now it recommends not hiring any of the qualified agents from the global south. So each recall for the global south is 0. And so the equal opportunity difference, which is the difference between these two, is -1 too. So essentially, these are agents is biased against the global south. So by being able to identify this bias, then you will be able to take action, modify your agents to mitigate this bias. Of course, you could perform further analysis. You could plot fairness against utility. You could generate different versions of your agent and plot their fairness against their utility to be able to identify which one gives you the most optimal balance between fairness and utility. And that way, you're able to develop an agent that is fair before you release it to users. Any question? Because I'll encourage you to try out this code and as usual, try to play around with it, try different. For example, you could modify the agent decision. Let's say this agent who is actually qualified and is from the global south. So indicating that our agent recommends I'm hiring that expert agent, and then you can rerun the thing and see how the metrics change. Yeah, now looking at our metrics, you see that the accuracy has increased to 0.67 because it has recommended one more data point. The prediction for one more data point is correct. The precision has also improved because the true positives have increased compared to the false positives. The recall has also increased because it's able to recommend hiring more of the actually qualified expert agents. And we'll see now that while the selection rate for the global north remains the same, the selection rate for the global south has improved. It's now 33%. This statistical parity difference has also reduced because now we've hired somebody from the global south, and the disparate impact has also improved to 33%, and so on. Well, if there's any question, please ask. If there's none, then we continue with. Okay,
Mr.
Kenneth, please go ahead.
What threshold actually marks bias in this metric, sir?
Well, there's no threshold in these metrics, but usually if the selection rate for any subgroup is less than 80% of that of other subgroups, then that is a appreciable bias and should typically handle that. So if the selection rate for any subgroup is less than 80% of that of other subgroups, then that's significant. That's usually considered to be significant bias, which you need to mitigate. But if you must not have 100% parity, right? Must not have 100% parity. If all know the subgroup with the lowest selection rate, well, let's say if selection rate is maybe 90 something percent of that of other subgroups, then I mean we could work with that typically. But I mean, based on your use case, you select your own threshold. You could select higher threshold, maybe 99%, as your use case may be, and your own tolerance. Trying to use that word. Kenneth, you wanted to ask a question.
Yes. I wanted to ask, is this the same as performing an evaluation?
This is an evaluation, but what type of evaluation are you looking at? You need to specify. This is an evaluation, quite right, but this is an evaluation of fairness.
Okay. Well noted.
Okay. So I'll stop sharing for now, and we get back to the slides. Please let me know when you can see my screen.
Very clear, sir.
Okay. So we move ahead. Now, it's time for some discussion. Here's the scenario. Is there anyone of us who has no idea what human in the loop is? We've talked about human in the loop in the early parts of this training. So yeah. So let's assume that our agent identifies that there's a 10% fairness gap in its own decisions, right? Like there's 10% likely, let's say 0.1 parity difference. So let's assume it and try this 10% fairness gap in this decision. But to fix this, to mitigate this gap, would lead to 5% decrease in overall accuracy of the agent's predictions. So what should the agent do? What is the best approach in your opinion? Should the agent automatically adjust its own logic, perhaps by what's the term, extracting rules into its procedural memory to help mitigate this? That could be an approach to automatically adjusting its own logic. Or should the agent, on the other hand, just pause and wait for a human to approve this action, or for a human to explicitly make this adjustment? What we think, which would be the most appropriate approach to addressing such identified bias?
Now try, sir.
Please go ahead.
Sir, my take will be that it will depend on the use case. It will depend on, let me say, the sensitivity of the being handled. Number one, we don't know, because number one, we don't know the current accuracy. We don't know how accurate it is initially. Not to now talk of a further reduction of 5% as a trade-off. So I would say each use case uh, might determine what should be done. But if I would give a general, I would say there's a need for the human in the loop to step in, or because we don't know how sensitive the accuracy may be. Because some use cases, a 1% accuracy might be very deadly. Maybe some things are classified as being, uh, let's say, positive, whereas if it is negative, the impact will not be much. But if it is positive, the impact might be very deadly. So such an accuracy is not comparable to the other thing. So I would say, number one, since you don't know the initial accuracy, having a 5% reduction might be very large. So I would say human should come in and approve whatever. So
Okay. Does anyone else have a different opinion, or would anyone like to add something to what I just said? This is a discussion. What do you think? Let's know what you think. Kenneth, please go ahead.
Okay. So um I will want the okay. So first off, I agree with what my brother said, and I will say the agent should stop and let the human like in the loop to take like precedence here because even though the agent might see the problem, it can't let's say um, presume like common sense. My computer only sees my ones and zeros, and it can't judge um, if that's my 10% and my gap is a tiny detail or a huge safety risk. So I will agree with what like, my brother said on that one.
Okay. Mostly you want to go. Mostly you wanted to say something, your hand is raised.
Yeah, I would like to. I just wanted, like, I agree with him. There should be a human in the loop because even like all the, with all the education of AI now and even like robotics, and many scientists and researchers are always promoting like human interaction, like machine.
So I can't hear you anymore. While we're waiting for be able to hear her, Daniel and David, do you have something to add on this?
Okay, regarding this, um, I would say it will actually be like it will be okay for a human to approve ethical trade-off. Yes, because we don't want to be uh, relying so much on machines to be able to make decisions.
I don't know if you guys heard me the other time. I got logged out.
No, we didn't. We couldn't hear you at the point, but David is speaking now, so let him finish when he's done with time. Um,
Okay, so because we don't want to rely on machines uh, making decisions for humans, and because we are the creators of AI, so it will be best if human does approve, even though at times humans might be limited, but for scenarios, for every event or scenarios, definitely I would actually suggest that human approved ethical trade-off. Yes, that's it for me.
Okay.
Thank you,
So
sir.
thank you for that, David. Nancy, please go ahead. Okay. Yes, we'll move ahead then. Or David, Daniel, rather, do you have something to add?
Yeah, hello. I hope you can hear me. Good evening.
Good evening. I can hear you loud and clear.
Okay, so maybe I'll just add my bit to it. I think when I agree with what everybody has said so far, allowing the human to take the final decision, because for accuracy, I mean the agents being more like a computer can easily calculate for accuracy. But when it comes to fairness, I think fairness is something that requires a human to, take a decision on, because um, like it's a matter of morality, kind of, and that's disparity. It could lead to so many consequences that the agent in this case may not be able to factor into its decision making. Yes, so I agree with what everybody has said so far, that the human should be able to make that decision.
Okay.
Thank
Alariwa, do
you.
you have this first? You go ahead. Daniel, you're done,
Yes, sir.
right?
I
I
just want
think
to.
yes, thank you.
Okay.
Yes,
Alariwa,
sir.
you go ahead.
I want to just add. Yes, sir. Thank you, sir. I want to just add a little to what I said earlier. That when you were teaching us the code, there are different metrics that were um, on display: precision, recall, accuracy, and so accuracy alone may not be a true measure of. Sometimes you may have maybe a 99% accuracy, whereas precision may be a more sensible metric to determine what should be done. Meaning that even sometimes we even have 100% or 99.9% accuracy, whereas that accuracy means nothing. So I would just also want to allude to the fact that it is important for human to come into the loop and decide if to determine how weighty the accuracy matter is. Thank you, sir.
Okay, welcome. Nancy, are you able to speak now? Okay. So right then. We're going to do another demo here. We'll be looking at the AI explainability using Sharp and Lime. I'm going to share my ID so that we can look at the code and then execute it. Please let me know when you can see my screen. Okay, thank you, Kenneth. Here, we'll use Sharp and Lime, and we are going to simulate the agent decisions like we did when we were in the demo for AIF 360. But here, we are just going to use random values. The features we will look at will be sentiment, complexity, is premium, and workload. Now, the scenario here is that we have an agent, let's say a customer service agent, that decides whether or not to tackle a customer's complaint to handle it or to escalate it for a human to handle. Now, sentiment refers to the sentiment expressed by that customer in the feedback they provided. Complexity refers to how easy, here for sentiment, 0 refers to an angry sentiment, while 1 refers to a happy sentiment. Then complexity is how complex is the issue about which the user provided a feedback, where 0 represents an easy issue and hard represents a difficult issue. Is premium refers to the customer's status. Is this a premium customer? If it's a premium customer, the value will be 1. That's like a VIP, while 0 is a standard customer. And then workload, how busy the agent is, how much maybe the agent's waiting queue, how filled is it? Where 0 is free and 1 is busy. We define a logic for a hidden logic for the agent's decision on whether or not to escalate, where 0 means don't escalate and 1 means escalate. And the logic is this: if the complexity is greater than 7, then it should be escalated for a human to handle. However, if the complexity is less than or equal to 0.7, but the sentiment is less than 0.2, and the complexity is greater than 0.4, and also this is a non-premium customer, this is a standard code. So if the complainant is a standard customer and the sentiment they expressed is less than 0.2 and the complexity of the issue is greater than 0.4, then the matter should also be escalated. So 2 conditions for escalation, 2 condition groups. 1, the complexity of the matter is greater than 0.7. It doesn't matter what kind of customer is or what the sentiment is or whatever, it should be escalated. But if the complexity is less than 0.7 or equals to 0.7, then if it is a standard customer and the complexity is greater than 0.4 and the customer expressed sentiment is less than 0.2, that means quite close to angry, then it should be escalated to a human. That's our agent's decision logic. Well, this is like a simulation. Now, we use a surrogate model. Yeah, Daniel, is that Daniel? Somebody raised their hand but has lowered it. Okay.
Sir, please, this is me.
Okay.
Sir, please, on line 21, I think you have to, I don't know if, because like you are using 2, should it be 1 or 2? On line 21, it's premium. So I see you have 0 for standard and 1 for VIP, but I see 2 in there.
Oh, sorry, it should be 1. Thank you for that. Thank you for that.
Nice.
Yeah. Thanks for that observation. So, yeah, what we usually do is, because this is an agent, we may not be able to apply sharp directly to that agent. So what we do is we train a surrogate model, a model that is supposed to simulate this our agent, so that sharp will now provide explainability to that surrogate by telling us what features drive the surrogate model's decisions. And since that surrogate model is trained on the decisions of our actual agent, the metrics that Sharp provides form a good representation of the equivalent metrics in the actual agent. So here, the surrogate we are using is a random forest classifier. And so we fit the input data that our agent uses, as well as our agent's predictions to this surrogate model. And that's the model to which we try to get insight into its logic and what drives its decisions using Sharp. We've plot the Sharp values, and we are plotting a B-swarm plot. We're going to see that when we run the code. Now for Lime, essentially, for Lime, we are trying to see it's still similar to what we get for Sharp. How Lime will tell us how relevant the values of each of the features is for a given data point. Sharp is giving us global insights. Lime will give us local insights, right? Lime will explain a specific point, a specific decision point for the agent, not the entire global scenario, but it's local, it's at a specific decision point. So let's run the code.
Sir, can you explain the between Sharp and Lime observation?
Let the data come up. That will maybe make that clearer. So here's our plot for Sharp. In this plot, the most significant features are at the top. See, complexity is the most significant features. So complexity drives the decision of the agent the most. I mean, considering that we are saying if the complexity is greater than 0.7, escalate. Only complexity. Once it's greater than 0.7, escalate. I mean, that's quite a weighty feature. And that's why you see it at the top, because it's like the most significant of the features. The next to it will be sentiment, and then we have workload and its premium. Okay, now the data, if this plots all the data points, so all the complexity data points, the ones to the left of 0 are the ones that drive the agent's decision in the negative direction. That means drives it towards do not escalate, resolve it yourself. That's the agent. While the ones to the right of 0 are the ones that drive it towards escalation. Hey, you can't handle this. Escalate it to a human. The points that are in red, let me finish it. We'll ask a question. The points that are in red represent those with high values. The ones in blue represent those with low values. The one that you have close to 0 means it doesn't drive the decision. For example, here, see, it's premium. It's premium. If it's premium, it doesn't really affect the decision. It's agnostic to points where where the client is premium. It doesn't escalate. I mean, if premium has a least impact on the model's decision. Now, these bulbous points are where most of the data for the given feature cluster, while the tails are really more like outliers. So you see that most of the complexity values cluster around here. You see some clustering here and all that. Olara, would you please ask your question?
Yes, I'm sorry. I don't know. Maybe it's my network. I expect that maybe I should by now see a visualization, but up to now, I don't know if it's only me that's not seeing the visual. Maybe
Please
others are seeing it.
indicate if you can see the plot that I've been describing.
No, sir.
Oh no, you can't see it. I'm sorry. I'm sharing the IDE itself. I need to stop sharing and share the plot. My apologies, please.
All
Just a
right, so
moment.
that's why I wanted to figure out.
Thank you, Olara, for pointing that out. You should see the plot now. Please indicate
Yes,
if you
it's
can.
visible now.
Okay. So I was saying that complexity, you see complexity at the top. That shows that complexity is the most significant feature driving the agent's decision. Of course, it's really the surrogate model system, but the surrogate model simulates our agent. The feature that provides the least is least significant here is premium. Now, the data points that are on the left of the zero line are those that drive the decision towards in the negative direction. That's towards don't escalate. While those that are on the right of the zero line are those that drive it towards in the positive direction. That's towards escalate. The points that are red are the ones with high values. The ones that are blue are the ones with low values. And these points like these are where you have a cluster of values for the given feature, while the tails are like outliers. That's essentially the summary of what this represents. So you can see that if the complexity value is within for these points plotted here, these values of these points here, most likely the agent's decision will be not to escalate. If it's for these values, it will be escalate. The key thing here is that complexity drives the decision the most. So if you identify that there is bias, then you need to investigate whether the truth is complexity actually a sensitive is it a sensitive feature? If it's a sensitive feature, then you need to try to adjust your agent so that it doesn't have that much of significance in the agent decision. Assuming you discover that there's a bias and you've been able to see from the sharp plot of the sharp values that complexity has the highest influence, then mitigating the influence of complexity would most likely reduce that bias. Assume complexity is what is driving that bias. If that's the case, adjusting, let's say, if you eliminate its premium from the logic for your agent, it will have little to no effect on the decision. So if you want to eliminate bias, then its premium should be the least candidate for adjustment. Any question? Okay, so I'll stop sharing the plot and we'll go back to the IDE so we can also look at the output for line. Please let me know when you can see my code. Oh, I need to rerun this. Okay, I just need to close. Un momento. Just a moment, please. Okay, once you can see my screen, let me know now, and we should be able to see the outputs for line. Please indicate if you can see my. Okay, good. So the line explanation, it's saying that for sentiment values that are less than or equal to 0.24, here is the impact on the decision for sample 10. This is, remember, a line is local. So for sample 10, sentiment value is less than 0.24. So this is its contribution to the agent's proportionate contribution to the agent's decision. The complexity is between 0.47 and 0.72, and this is its contribution to the agent's decision. Now, notice here that sentiment is driving the agent's decision towards escalate, while complexity is driving it towards do not escalate, right? And then for workload, the workload is less than 0.2, and this is its contribution. It's driving the agent's decision towards don't escalate. And then its premium is less than or equal to 0. It's actually 0 because it's not a premium customer. And it really doesn't have any effect in this case. This is contribution, which matches what we saw in the sharp plot, because for its premium, it was on the 0 line. So its premium here is not driving the decision at all. What is the contributing mostly to that decision is really the sentiment. And here I also displayed the actual values at that sample 10 so that we can see. Sentiment at sample 10 is 0.02, which is less than 0.24. Complexity is 0.61, which is less than 0.73. Remember that our logic is escalate if sentiment is greater than 0.7. So really, sentiment here is less than 0.7. So it will actually push the decision towards don't escalate, which is what line is showing us here. Not sentiment, sorry, complexity. Sentiments is just a moment. Let me get that logic. Yeah. If sentiment is less than 0.2, then it drives the agent towards escalating. And at this sample 10, sentiment is 0.02, which is quite lower than 0.2. And that's why it's having this much impact on the decision and is driving it towards escalate. Complexity, okay, we've already talked about complexity. Workload, the logic says if workload really doesn't have much impact on, it's not part of our logic. And that's why you see the impact it's having is this low. It's quite close to 0, 0.0024. This also matches what we have in our logic. The value for workload is 0.22. Well, workload really is not part of our logic, so it's not even something you should bother about if you want to mitigate any observed bias. Does anyone have any question? Okay, then. So I'll stop sharing and we'll go back to the slides. Please let me know when you can see my screen.
It's up already, sir.
Okay. So, another discussion. Here's the scenario. Let's assume we have a banking agent which has 98% accuracy in predicting loan defaults. So, its prediction of loan defaults, 98% of them are accurate. However, when we do a sharp audit, we find out that the agent is really assigning a lot of weight to phone model as a feature. Now the question is phone model really a legitimate proxy for financial stability? Does your phone model correlate well? Well, correlation is not actually causation. Is phone model a good determinant or a good indicator of financial stability? Because usually people usually default from loans when they have low financial stability. So is phone model a good indicator of financial stability, or is this just a proxy that introduces bias, be as it's being used here for socioeconomic status, this context? So what do you think? Yeah, Lara, go ahead.
Okay, sir. I will say yes, sir. So
That phone
depending
model
on the
is a legitimate proxy for financial stability.
yes, sir. So depending on the universe of phone, depending on the context of the decision making, because if someone is a high-end phone user, and also depending on the amount of loan anyway.
It
So
doesn't matter the amount of loan in this case. The context is clear. The agent is 98% accurate. So it's able to predict, 98% of its predictions of loan default are correct. But when you perform a sharp audit, you see that its decision is heavily influenced by phone model. So people who use certain phone models, probably high-end phone models, it probably sees them as they are unlikely to default. So that's a clear
okay, in that
context.
case, sir. Yes, I get your point, sir. In that case, I would say it's a bias. It's actually a bias, sir. Because even as it stands, the accuracy is a bias, sir. It's a
Okay,
bias.
why do you say it's a bias and that phone model is not a fair, a good, not them not say
Okay, sir.
fair, that it's not a good
Um,
indicator of financial stability?
why I say so is because number one, there are different phone models. So while it is possible that the model is getting it wrong, even the accuracy, like I said before, accuracy alone um, may not be the only indicator. You know, maybe we should look at maybe the precision, the F1 score, and the likes to know. But given that we have been told here that it's 98% accurate, we don't know the number of maybe it's only 2 or 3 or 4 only, or maybe it has up to 10,000 for the accuracy in number. But then your question, rightly, sir, you say, why do I think phone may not be? I mean, phone status, the model may not be a legitimate reason to, I mean, a good feature to predict whatever. Unlike my initial decision that I said, because I was thinking, depending on the amount of loan, but we said we should forget about the amount of loan. But I was thinking initially, if in the range of maybe 20 million naira, 30 million naira loan, and someone is using a phone of 1,000 naira is asking for the loan, it may likely be a feature. But I, however, changed my mind to say it would be a bias because the phone as a feature alone cannot be used as a timing factor. It might be misleading it among those accuracy. Even though the number out of these accurate measures that were influenced into that decision making, because it won't be all of them that are high phone users.
Well, Sharp is a global provide global insight, so it means that majority of the decisions, phone model influence majority of agents' decision.
Wow, it's actually difficult for me to, but I would say it's not. Might be a bias. Might be
Okay,
a
anyone
bias.
else? No one else? All of us, we should speak. What do we think?
All right. But say I think it is not going to be fair, that because I may be like somebody might not be using a good phone, but maybe like they might have a good like records. So it is a bias. Yes, it is unfair because
Okay.
there might be people who might be having a good record of maybe paying their loans back and all of those things, but their priority in life is not centered on having a good phone model. So I will have to say it's a bias, please.
Okay. Anyone else? David, Daniel?
Yes, sir. Okay. In as much as the banking agent is 98% accurate at predicting low defaults based on phone model as a feature. Mm, Now, the thing will be, can it accurately predict uh, loan default from a user that is, or from a client that is actually using a low-end phone, even though from the person's background can actually afford to collect the loan and repay back? That's the thing. So if it's not accurate in predicting that, then I'll say it's actually biased. Yes, because not all persons who have high-end phones can actually are actually financial stable financially. Yes,
Okay.
they can be determined by that. So it's biased.
All right, Daniel, what do you think? Daniel, are you there?
Yes, yes, I'm here. So, sorry, I wasn't paying full attention, but I would also say, using the phone model is a bias because somebody using a high end or a low end phone may or may not, I mean, be a very good determinant. Somebody using a high end phone could probably have gotten it, I mean, as a gift from somebody. And somebody also using a low end phone may just be that person's personal preference. So I think it's a bias, and I mean, it should kind of be taken with a grain of salt. Thank you.
Okay. Okay, so I agree with you all that phone model really is like a bias proxy for socioeconomic status. Yes, somebody using phone model indicates that the person has will typically belong to a certain stratum of the society. But however, it doesn't necessarily indicate financial stability. Somebody can be actually a low income owner, but has some. I mean, loan repayment. One thing that the bank cares about is trend, right? Even if the person who has a high end phone bought it themselves, it could be that at some point they had a windfall and they exploit that on the phone. And after buying the phone, they don't have a dime anymore. So really, this model is biased. Yes, quite all right. Incidentally, all the people that it predicted that they would default end up defaulting. Obviously, those people have low end phones. But there may be somebody who has a low end phone who can actually, who is quite financially stable, like you mentioned, and can pay. But because this agent decision is being driven by phone model, it's going to predict that that person will default. And there may also be people who have high-end phones that are not financially stable, and those people are going to default. And even for such people, they may have taken a huge amount as loan, and that's quite a bigger risk. So essentially, phone model being the primary driver of the agent's decision is highly biased. It's not a legitimate representation of financial stability. Okay, one more scenario. We have an agent that controls a drone. So it's an autonomous drone. Now, this our drone is sent on a mission. So it's given a task. It's supposed to autonomously move, go and accomplish that task. But it decides to abort that mission. It decides not to continue the task. And when we perform a line audit for that particular task, we discover that the decision to abort the mission was driven by unknown shadow. The drone saw an unknown shadow. And this decision, it has a 90% correlation. So essentially, that's actually more or less what influenced that decision to abort the mission. Now, it's clear, this explanation. There's an unknown shadow, and because of that, the drone aborted the mission, probably because, this is an unknown factor which could, if you continue the mission, there could be serious issues, whatever. The important thing is that this is a clear explanation technically, but to a human, what does it mean for the agent to have observed an unknown shadow with 90% correlation? What really does that explanation mean to a human? In typical human conversation, you don't explain, hey, I saw an unknown shadow with a 90% correlation. The human would typically say, hey, I think I'm seeing somebody here, but I'm not so sure. Something like that. So the question is, such an explanation that does not use typical concepts that humans use, would such an explanation really count as explainability? Would this qualify as explainability in AI? This explanation that uses concepts that typically not used by humans, would that qualify as explainability? Your opinions, please. Or maybe, I think our time is fast spent, so I think we are going to let's have this discussion in this Discord channel. So the same thread where I posted the post I made about where I shared the code, the scripts that we use for demo. Respond there and indicate your thoughts on this second scenario. That will round off because it's already 10:30 here. We've already taken a bit of extra time for today. And so that's basically what I have for you today, unless if you have any question on observation, please let's hear you. Otherwise, we'll just call it a day. I will be taking on Thursday. Okay, there seems to be no further questions, so we'll call it a night. And thank you very much for being active listeners and active contributors to our discussion. We'll meet again on Thursday to continue our discussion on ethics and safety in agentic AI. Thank you very much, and good night.
Thank you, Seth. Appreciate your time.
Good night.